I like it. Who is right now working on breaking their big monolith code into like microservices? Else on the monolith or on the microservice already? Okay. Who has problems running microservices in production? Okay. So if you don't have problems, you can leave. Right? Okay. So I'm going to show what we've learned going through all of those stages, breaking, migrating the old code into microservice using Docker. Sorry? I'll get to that. First, I'll just want to touch a little bit on the interesting story. I heard an adaptation of an old story to the modern world. A guy finds a genie bottle, and genie pops up and says, "Okay, you have one wish." The guy says, "You know what? Like, I hate flying. I hate being, but I've never been to Hawaii. I want to go to Hawaii. Please build me a highway to Hawaii." So genie says, "Like, are you crazy? You know, like how much it costs? You know how hard it is to put those like columns into the ocean floor? How hard? Like, what's the environmental impact? We're going to kill a lot of species. You're crazy. You have another wish. Try something else." So the guy says, "You know what? Like, we're right now breaking our monoliths into microservices, and we're trying to run the production. There are a lot of problems. We need some help." So Ginny scratches his head and says, "Like, you know what? What do you have in mind? One way or two-way highway?" Right. So that's more or less where we've been. But it's coming. It's getting easier and easier every day. I'm going to walk you through like what we've learned dealing with all those issues. So I'm going to tell you a story today about cheese, but this is not actually about like I love cheese, I love like all kinds of cheese, but we're not going to talk about not the like real cheese, but about the story written by Spencer Johnson about dealing with change in business and life. It's a great story. You should like everyone needs to know about this story. So why I'm talking about this? So I've worked. Like, my name is Igor Moochnick, and I worked with or for a couple of like pretty big companies. And almost in every company, we had the same, more or less the same repeating story. Like big code, legacy code, make it work now, right? So we've accumulated a lot of interesting ways of dealing with those problems. And actually, since today, I'm back in consulting because I want to share with other people all the learnings that we've acquired. So when I'm saying we, it's kind of like an amalgamation across like multiple different companies. So across the last 2 years, I back 2.5 years and consulted for a couple, like advised for a couple of other companies. So when I'm saying we, it's across all those different projects that we've been running. So the story starts with there are a lot of cheese sitting in one single place. And the business is getting used to that. There are a lot of stuff. It's very well known. Big monolithic code, legacy app. It's sitting. Everybody's happy. Developers are happy as well. They can load the whole code into their development environment, put breakpoints. It all sounds nice. And having cheese makes you happy. The business gets used to that. The business is humming. Everybody's happy. The infrastructure is known. Everything is known. We know how to deal with change. We update code. We schedule downtime. Everything is nice. Like more and more change starts to come, and we're starting to go because the more important cheese to you, the more you want to hold on to it. You don't want to introduce a lot of change in the infrastructure because it makes you unstable, unhappy. So we're putting a lot of like approvals in place, change requests, maintenance requests, like tickets, and we start to guard it. But the paradigm shift is happening, right? The business starts to feel the pressure from the markets. The business needs to react faster and faster to the change. So they're starting to put pressure on the development and the systems organization, operational organizations to adopt more and more, to react faster and faster to the change. And we're starting to see the shifts from stable environments to more like reacting to customer requirements, making customer happy. We're starting to see shifts from the waterfall to agile, and the infrastructure and the operations, they starting to struggle how to react to that. But the business understand that if you don't change, you can become extinct. So we're starting to see slowly the operational teams and systems teams start to adopt virtualization and starts to think about clouds, starting to bring their private cloud to public clouds. And this new things pops up, like, and getting sort of excited, but still don't know what to do with that, right? There's a lot of talk about, is it like yet another virtualization? Is it hype? What's happening? But then the interesting things happening. So if you can see the trends of the adoption, virtualization compared to containers, right? This is graphs taken from Google Analytics on the interest on different topics. So you can see that virtualization hype happened kind of like within 5 years, and the Docker surpassed this rate within 2 years. Am I going to explode here? Okay, cool. So the adoption rate starts to grow very, very quickly, and the organization, a lot of organizations starts to think about maybe there's something, and everybody starts to think about like how to adopt it. And everybody starts usually slow. Okay, let's figure out what to do with that. Maybe the very, very first thing we'll do, we'll start isolating our builds. Because usually when we have a build server, we need to install like a lot of dev tools there, keep it always stable, because it's becoming very important to our release cycle. That's where almost every company that I observed over the last couple of years, that's where everybody starts. Using Docker plugins, for example, there's Jenkins, starting to get very nice stable builds, build environments, everything is controlled, everything's nice, but it became, in the organization, starting to adopt very, very high velocity release cycles. It didn't really work because it was time to bring this new development environment, the new build environment into the, they're starting to be cached. But then you release a new version of that and it's like cycles begin. So it didn't really work. A lot of issues becoming also like a lot of like companies starts to figure out like how to deal with the Docker hosts and how to deal with the network storage for those containers. And we'll get to that in a second. As soon as the company starts to learn about the containers and how they work and they understand their limits, then we're starting to see that team starts to embrace it. And it's like really, really becomes very, very excited. Everybody gets very around that. And we immediately, this is very well correlates with the shift to microservices. So we see the speed of the deployments starts to grow, and the requirements for the increase of speeds of deployment starts to grow. So before that, we had data centers where deployments were, each server was different. It, like barely anybody knew how it got to that state. Then we started to move to virtualization. With virtualization, we figured we can have images, we can have the process repeatable, and the deploys that went into those virtual machines, they were staying a little bit, the life cycles of them, they started to shrink, like to weeks and months. Now with high velocity releases, like in the very well cultured organization that adopt DevOps and like short iterations, we're starting to see that the release cycles, they're shrinking to multiple times a day. It's very, very common, right? So the speed of bringing up virtual machines is not good enough because developers, they want to try and test their code on very, very, very short iterations. And this is where containers actually started to shine. But then everybody starts to ask a question. So if we work on application, then what actual application is for us? Is it a single container? So everything that we had in the virtual machine, why don't we pack it up into container and just deploy it as it is? We can enjoy all the benefits that container bring, right? But then how are we going to maintain it? Like different components inside that container start to change, so we need to release a new version of container again and again and again. So that doesn't really quite work. And our Docker guidelines suggest to think about single responsibility, where create a container for each different functionality. Like if you need like more or less one per process, or if you need a tool or a test tool, put it in its own container, and then use composition, put them together. So then we starting to hit the limits where a Docker ecosystem doesn't really quite work, there are a lot of missing gaps there. And we started to see a lot of tools like Fig, and now it's called like Docker Compose. They start to pop up here and there and start to get proliferation. But then different frameworks, different tools, different systems, they didn't really know how to deal with that. Now we're starting to see more and more systems implement that notion in their ecosystem. For example, Kubernetes, they call it pods. A pod is a composition of the container that can be collocated in one machine. They have to be collocated in one machine. In Amazon ECS, we here they call it task, which is, to my taste, it's a little bit misused, maybe like overused term in here. But then if we have an application as a composition of containers, in many cases microservices, actually we need like a bunch of those applications work together. So we're starting to get into a graph of containers that can be spanning across multiple machines. And this is where a lot of issues right now happening, and very little existing systems that know how to work with Docker and container virtualization, they totally lacking any functionality in that space. And we'll talk about this, how we solved it. But really about containers is that allowed us to create immutable artifacts. A configuration management, which we really, really love, and we got used to that, has some issues with the drift, because many cases, if you keep a server up and running for a long time, the changes, they accumulate, and there is happening in drift. If you copy the files, if you next iteration don't need that file anymore, you need to figure out how to take those files away. So have you guys experienced the configuration management drift? Yeah. So I think everybody likes, like, after we get excited about configuration management, we start to learn about this, we're starting to see that. And then then you start to think about, if we're running on the private cloud or private data centers, how can we make sure that those servers, they don't experience the drift? So we need to figure out how we rebuild them constantly and very, very often. But this is where containers are awesome, because when it got dirty, you kill it, you bring a new one up, and you kind of back at the beginning state. So on the other hand, when you're starting to work with, like start to move, let's say, to DevOps route, to hear things where you need to version everything. And containers are like awesome at that. Configuration management doesn't really, if you specifically do it wrong, like a monolithic configuration management, where everybody starts, where one repo represents the center, it starts to be very, very hard to say what actually specific configuration at any moment in time of any server, right? So you need to think about how to separate each configuration management of each server separately, right? So there are a lot of ways to do that. If you're using Chef, for example, you can use Bergshelf, Puppet, if you're using a Puppet librarian. So there are ways to do that. But Docker makes it very, very easy. So we started in that place, but we very, very quickly saw that the release process itself started to not only drift, but accumulate a lot of knowledge about how the artifacts move through the process end to end. So we even got to the place where we brought a tool that allows us to version the whole release end to end. And we open sourced it. You guys, you can, I will not get into that. But so we got to the point where everything is versioned. Servers, containers, release process, the code. And it got us to this, got us to about how we're going to deal with the whole release process in the new light when the Docker comes in. So the usual release process we end up with where developers commit code into repo. It keeps storage. A lot of different artifact storage we use. The one that I really like Artifactory. It's really great. As soon as the artifact is created, this artifact is saved along with extra metadata that we'll talk a little bit later why we need that. That talks about not only the version of the artifact, but like what's the contracts, what's the contract versions, what's the dependencies in need, what's the dependency of the contract version dependencies need. So that allows us to track its dependency. And we'll talk about this a couple of slides later. As soon as the artifact is created, the next step kicks in, which bakes a Docker container. So Docker container, after it's created, is versioned with the same version as an artifact itself. And it's uploaded to Docker registry. Different types right now of Docker registries. You need to think about which one you choose. You can deploy your own on your local data center if you're worried about privacy. But you can use Docker Hub as well. And they also provide you private repos. But you need to think about like what would be the time for you to bring this artifact back to your data center. So Artifactory recently, they released a new version that also works as a Docker registry. So it was really played well for us. And then it goes into deployment. So there, let's talk about, sorry, skipped the slide. So let's talk about the challenges that we had with the Docker registry. So when you start to talk about Docker registry, you need to keep in mind a couple different things. Who can access those containers? Who is allowed to change containers? Who is allowed to upload new containers? And after you solve that, you need to think about how to keep that registry all the time, because it's become very, very quickly, since Docker creates extra containers, it's very, very quickly starts to consume. So the storage is cheap, but you need to make sure that you actually give attention to manage that storage. And if you go back to my point when I said that the artifact has a bunch of metadata, so we started to use that to make decision what containers or what artifacts to prune from the artifact storage and the registry, because otherwise it's becoming totally unmanageable. The sizes just grow very, very rapidly. But since each artifact is hard versioned, even if we prune the artifact that we still need, we can always recreate it from scratch to exactly the same point. So after we solve those problems and we manage our registry and we put the artifact in the registry and the Docker into the registry, Docker container, then we need to go into deployment. And this is more or less, we knew how to deal with that. We still go back into our well-known configuration management where we use it to configure Docker hosts. They don't change that much. Only they change with the speed when Docker releases new versions of their product. So as soon as the Docker host is available for us, the orchestration pulls in the Docker container and starts it. But this is where we started to run a lot of different interesting issues, because we need to figure out at the beginning what the application is. And we ended up with a place where application is not one container. Application is the composition of the containers. So when Docker starts, Docker itself out of the box doesn't know how to launch the composition container. You just need to launch those containers one by one. So you need to have a mechanism that knows how to compose them together, right? We looked at Fig. We started to use Fig. But then we ran very, very quickly into the problem that the time of starting of the container and application side of the container takes a little bit time. And then when the services starts to want to find each other, they actually can't immediately, and they start to fail. We'll start to run into problems where containers needed to be initialized with different settings based on the environment settings, maybe secrets, different certificates. And Fig and Docker Compose till today, they still don't know how to deal with that. So all that, and we started obviously to write our own. We also figured out, which is today is more or less known, when you build containers, as much as possible, remove any settings from those containers and make them external, because otherwise you will need to make different containers for different environments, for developers, for production, for testing environments. So this is a big point here. Do not bake any settings. Make containers as generic as possible, and use the external and ideally hierarchical configuration settings management systems. So a couple places we use console, a couple places we use Zookeeper or Hira. There are a bunch of others that you can use, right? But this is important. And talking about secrets, you need to think about and talk with your security teams how those secrets will be ending up inside the containers, how they will be provided to your services that's running. And just to keep in mind, environment variables, they're visible if you do Docker PS. They pop up on your screen. So if that is, your security team will tell you, like, no, think about maybe you'll give those secrets through maybe like mounting different partitions or volumes, or maybe keep those secrets in different containers and ship them from different places. So it's very, very important was to start thinking about secret management. And we use a couple of other systems, like, again, like console or etcd to manage our secrets. But then we started to run into another problem. We started to experience container sprawl. Creating containers is very, very simple. And we started to get millions of them, literally, all over the place, everywhere. And we different questions like, what do we actually need to have this container running, or it's still some shred from the previous orchestration that wasn't cleaned up? Who actually the owner of this container? And it's not only containers that's running on a Docker host, but also containers inside our registries. So what to deal with that? There are like a ton of them, like a ton of different versions. And you start kind of like starting to lose there. And in many cases, all those containers, when they previous version of Docker, and still today we see that when the container, Docker says it launched the container disappears. So it may be like either crashed internally or Docker didn't handle it correctly. So there is still some issues there. So keep in mind that you need a very good eye on those things. But also we started to see a lot of containers that we see them as operational, but nothing happening inside the container. So we call them zombie containers. What to do with that? Not always you know if this container is actually doing something or is just like sitting around and doing nothing. So after we solved that, to a certain degree, we also started to ask questions. Okay, so we know how to build the containers, we know how to start the containers, but how are we going to test that? And this is, in many cases, this is a separate discussion about like start to think about microservices. You needed a very, very good to put a lot of thinking how you're going to do that. There are a lot of ways to do that. But what we learned about Docker is that the way how we start containers in production, they're way different from the way how we start containers in the development environment. In many cases, developers, they're really, really excited about Docker because they can run like almost the whole environment, or actually a big chunk of the environment on their development machine. The containers are very, very lightweight. This is great. But we also want to make sure that developers, they test the containers or application or the environment in the same way how it will be running production. So we want to make it as close to production as possible. And this is where we started to run into some kind of like split brain. So we want to be close to production, but we actually can't do that when running in the container. And in many cases, or actually composition of the containers. And in many cases, you also have a bunch of systems that developers need to integrate that you can't even put in the containers. Some like legacy system or some systems that require special hardware, right? So in those cases, you need to think about how you're going to do that. So one of the ways we dealt with that problem, we built another tool called BigRig that allows you to define different environment, different ways, kind of like Docker compose file, but for environments. So you can, each environment is kind of like Docker compose on its own, right? And that file is committed with the source code of the artifact itself. So that way, the same code again kind of used in production and development environment, but the tool does it differently on the production development environment. So it kind of helps to bridge the gap. So all that stuff we needed to figure out before we actually went first time into production. But that made us very, very comfortable with the technology. So we thought that we figured out all of the kinks. We thought that we got it to the point that we can manage it. and we went into production, and our developers started to be very excited about that. Everybody started to invent new things, how to deal with this new technology. This is a very exciting time right now. Those technologies are still in flux. So there are a lot of inventions going on. So but then this is what happens. Like that. So you're starting to get to the point, which is we always wanted to build microservices. Wanted to make services so simple and easy to manage and control, and full service for each function. So we started to go developers crazy with the services. We're starting to get like thousands, millions of them all over the place. So I like to say it like, why bad things happen to good people, right? So that you can see the graph from Netflix. This is the graph from Twitter, and there are a bunch I found. So all the companies that are really embracing those services, they kind of end up there. And you need to make some sense out of that. So you usually, again, kind of fall into the state. If you're changing something, do you really know what you're actually changing in this environment? So we fall back into, let's start guarding our environment. But this is not really what we wanted. We wanted to move away from the environment. So to deal with that, we built another thing to control, actually make sense out of our changes in the environments. So you need to have a good change management. And ideally, it's not the system that has a very human-centric or human-involved process for approvals, but the systems that keep a very, very good track of what is happening in each environment, in each data center. You need to know who changed what, when, what versions has been changed, what is deployed, what is deploying right now, what is changing right now. So it's becoming very, very important to keep track of that. So this is a system like Janos, for example. It has a built-in mechanism that, since it knows the dependencies of the services, it can make sure that the services that depend on each other, they will not be deployed at the same time. Because if you have a lot of different changes at the same time, to like services that depend on each other, if the failure is happening, you don't know where it came from. Did it come from the new deployment? Did it come from the new version of the code, like service A or service B? So you need to pay a little bit more attention how you're going to manage all this change. So this is also open source, called like part of the accordance system. But then you need also to keep a track of all those dependencies of the services in order to become smarter about the change and how to control the change. So going back to my point, as I mentioned, like if each service, each artifact has a declaration of what it needs to be successful in the production, or then the system, like for example, accordance dependency management, can help you to keep track of all those dependencies. And you can navigate, or anyone in your organization can navigate those dependencies and make sense and see what depends on what, and if a change or maintenance request is happening, what items in the environment they can touch or change at any moment of time. So after that we actually need to know about the dependencies, we start to run the problem how we're going to find those dependencies. So going back to our original point where we had more or less static data center, we learned how to deal with that more or less by putting a lot of DNS records all over the place. So our service A that needs service B has an entry in their DNS resolution to say that service B is located at b.company.com, and b.company.com resolves to that IP. So that's how they can find each other. It resolves to not to service directly to a load balancer. But when you're starting to have like thousands of services, that system doesn't really work well. Specifically when you have composition of the containers. When you're starting to have a composition of the containers, that really doesn't work. So when we started to move to microservices, we actually started to move more into service discovery, move the services to service discovery to move away from Docker linking and Docker composition. But then the service discovery actually needs to know when it connects the services together, it needs to know about the state of the application, if the application is running. And this is where we start to run into my previous point, as I mentioned. Or the system needs to know very, very well if the application, after it's starting in that composition of the containers, is it actually healthy? Can it receive any traffic? And that's becoming very, very not trivial problem. So when you're building your services in the containers, keep in mind that the container starts much, much faster than the VM. So when the Docker says that the container is running, your application may not yet running. So with the VM, when we were using virtualization, it takes more time to start VM, and the application more or less catches by the time when the VM is ready, application may have enough time to stabilize. But then Docker container is becoming acute, the difference between when the container is actually launched, or Docker says that I've started the container, and the application actually keeps up with the start process. And by the way, you can stop me anytime if you have any questions. So make sure that when you're building your orchestration or using any orchestration, that orchestration actually knows how to deal with that time. So put some stagger in place, or put some like time from the moment when you start the container or you run. Or in one of our tools that we've implemented, when the tool was starting those containers and composing them together, it had a check information in that configuration file to say what it needs to pass before it actually launches the next container. So in this case, it helped us to make sure when we start applications actually running. So that brings me to the next topic of monitoring. This is becoming very, very important. Before that, we knew that monitoring is important and alerting. But now when we start to have way more containers, way more application services, it's becoming even more important, because we need to make sense out of everything that was launching. So we learned very, very quickly that I need to start thinking about composite SLA metrics. Do not monitor the app and the container itself, but do not monitor the application in the container. Monitor the health of the whole application or service across multiple containers. So as the story says, you need to smell the cheese as often as you can to know when it's good or not. If it's not good, just kill it and start a new one. It's much. But we started to run very, very quickly to the problem that the modern monitoring tools, they don't know how to reason about the containers. Every tool more understand about the container, that there's multiple zones contain environments, contains machines, virtual machines, Docker containers, and so on. But in reality, that doesn't really work. And specifically when we start to have multi-region, multi-data center applications, like simple examples like Cassandra, Hadoop, when they spanning across multiple servers, the fact that it's failing in one data center doesn't mean that the whole application is down. It means that maybe it automatically needs to provision that we need to raise like whole hell of alarms and start saying that we're down. It's not really. So think a lot how to configure those monitoring tools. And specifically, if you're using anywhere relies on the server names, just stop doing that. You will not possibly keep up with that, because there are like thousands of containers and they're constantly coming up and down. So those tools, they cannot keep up with this change. And specifically in this case, I just given a small example here. So what is happening if the machine, a virtual machine, is like misbehaving? Then like everything inside misbehaving, or if there's just the storage fails, maybe a bunch of the containers starts to misbehave. So it's very important, after you detect it and monitor the application and you identify that it's failed, you need to know how to deal with the failure. In many cases, then the failure, it means just you need to shut it down. But when you're shutting down, you also need to remember that it's not a single container, it's the whole composition of the containers. And in many cases, the composition of containers, some of the containers, they have to be running in order for application to work. And some containers may not be running for application to work. I'll give you an example. What if you have application that writes into a log partition and the log shipping container died? The application continues to work, but one of the operational containers died. So in this case, the system can just restart the container and declare the whole instance to be dead. So orchestration tools not always understand that difference, right? So we needed to write a lot of logic to deal with that. And you also need to remember you can just kill and dispose of them. Some containers may not, because it may contain some information that you still need. Maybe like for troubleshooting, or maybe some data that you need to ship out of those containers. So when you shutting down containers, keep that in mind. So I'll very briefly touch about that. So please do not put your production data in containers, because the containers disappear very quickly and you will lose all your data. So think about either mounting the machine storage or more resilient storage to your containers. If you need to keep, let's say, database, you can run the database process inside the container, but it's like the database itself do not keep inside the containers. There's a very interesting development. I'm monitoring what's happening inside Flocker. They have some mechanism to move the container from one place to another if it fails on one machine. But just keep in mind that the size of the container, size of the data inside the container can be so big that may not have enough time to ship it over. Right? So just keep in mind. So log management. This is one of those pieces of data that you may keep. And today we encourage to write a lot of logs. This is great. But also think about this. If you have thousands of containers, the amount of data that you generate in logs become just, in many cases, prohibitively large. So put mechanisms that allow you to control how much data and when the data is generated. But today, one of the suggestions is to write your logs into Docker, and then you can use Docker logs to look at what's happening. But remember that data stays inside the container, and it's actually always accumulates. It always will start to show you a log from the beginning, and not from the place where you're running right now. So we learned that we just don't write to standard output. We write always to the log file, and we mount either like another Docker container to keep those logs, or we mount machine storage. And ship this data very, very quickly from the containers, because again, as I mentioned, the containers disappear very, very quickly. So that was our starting point to the Docker. And we learned that we needed to be very, very quick to adopt those new findings that we found out. And that brings us to the topic of Mesos. So after we've been building all those tools to manage and orchestrate those containers, Mesos shows up and helps us very, very quickly to make some sense and even simplify our orchestration. So Mesos became very quickly a top level Apache project. It allowed us to, and I'm talking for the moment on the inside data center, allowed us very efficiently use our servers. But then we also learned it has also a great benefit to run it inside Amazon or any other cloud, because it allows us very, very quickly spin up new servers, spin up new containers and shut them down. So for short running processes and tasks and batch jobs, it's great. So you can very, very, very optimize there. So I'll do a couple of shout outs to different frameworks. So we use Marathon in containers, and it's great because if it dies in one place, it pops up in another place. It was great. Kronos was awesome to run batch job and like processing jobs, but we ran very, very quickly to the point that we needed to connect queues of jobs to those batch processing, and that functionality is missing in Mesos. So we've wrote a couple of our extensions, which is not open sourced yet, but maybe soon, that allowed us to connect the queues to Mesos scheduler. So Singularity from HubSpot and Aurora from Twitter, they kind of help us to solve that, but we failed miserably to start them on our own data centers because they were not mature yet. But we continue to keep in mind to check them once in a while, and we hear good things that are coming. But one of the things that really impressed me is what new development from Netflix called Mantis. It has Fenzo as distributed scheduler, and Scryer is predictive auto-scaling. So they're building it to run at Amazon. Really, really exciting stuff happening. So pay attention. So we learned very, very well that Mesos helped us to manage Docker container both on public and the private cloud. We were very excited when Mesos started to support Docker out of the box. So Mesos Docker, it just simplified our life very, very much. But there are a lot of missing still features in Mesos. Multi-region management, persistent volumes. It still doesn't know how to manage those composite containers. Missing REST API, so I will not go there too much, but it's still young technology. And if you're thinking about that, just keep in mind its limitations. So change happens very quickly, and the constantly moving cheese. The technology is constantly changing, so just stay on top of the change. It's a very, very exciting time right now. So a couple new things that what we're looking at was we really paying a lot of attention to development of Kubernetes. It's still a little bit early. We're still missing a lot of, as I mentioned, like the linking of the containers. It didn't work across the machines. I just heard today from Jerome that there is new Docker that's supposed to help us, and we're excited. Maybe like we'll check it out very quickly. Lambda architecture is very, very promising, but we still ask questions. If we're running on-prem, what would be an alternative? So we kind of looked at Storm, and we're using Storm very, very heavily, but we would like to see something like Lambda, some alternative running on private data centers. Tracking is, we very heavily working on that. We need to make sure that when the failure is happening, as I mentioned, like to reason to make sure that our monitoring and alerting tools, they know how to reason and understand those dependencies and those. And just I'll do one last shout out. When you have all those dependencies of the services and you're having a lot of them, you very, very quickly start to ask a question, how's the data flow through the system? You're starting totally very, very quickly to lose the tracking system. And I'm very excited looking at a lot of different companies, they building tools around this, open source yet. So Salp from Netflix, they kind of can build a graph of data flow through services, and Hello, they build something of their own that even builds the time series diagram. I'm building right now part of Accordance that will use Argus as open source tools to kind of like automatically detect those dependencies. So that's exciting. So I have to do credits, and if you have any questions, you can always find me. As again, I mentioned that I'm looking to help other companies, and really excited to hear about your challenges that you have in your environments and your systems, and to hear about how you solve them. That would be great to share. Thank you very much.